All right, so we're going to work through one of the math modules on the new digital SAT. This is from the Bluebook app, and it's the second of the tests. So if you haven't already done test 2 in the Bluebook app, don't watch this video until you do it, okay? Because we're obviously going to go through the answers. And the goal of this video is just to see how many questions we can use Desmos on. I just want to show you how often we could use it, and you've seen our other videos maybe, and I just want to demonstrate the basically the power of using it, and yeah, just show how often we could use it. So I'll stop talking now. Let's go into this. So this is the Bluebook app. This is what the test is going to look like when you take it. This question is pretty easy. You could probably figure out how to do it without Desmos. However, if you really wanted to use Desmos, you could. You just click the calculator. Which equation has the same solution as 4x plus 6 equals 18? Well, in Desmos, you can type in 4x plus 6 equals 18. And you can see this red line goes through 3, which means 3 is the solution. So if it's going to have the same solution, it has to also have a solution of 3. So now in Desmos, I can type in all the other answers. 4x equals 108. And you can see if I zoom it out, that has a solution of 27. Obviously, A is wrong. I can use this tool here and cross out A. What about B? 4x equals 24. That's going to have a solution of 6, not 3, so that's wrong. And when we go to C, we're going to see that it has the same solution of 3 as the original problem, and so C would have to be the answer. Okay, so you don't need Desmos on that, but there's definitely a way to use it, and you could see from the picture that it's pretty easy once you know what you're looking for. Okay, this one, we really can't use Desmos for this. We want the value of W. This angle is 170, so that means that this angle also has to be 170. These are corresponding angles because these are parallel lines, M and N. So W is also 170. Next, let me get rid of this for now. The mean height, we can use Desmos for this. Go back to it and clear this out. So the mean, watch what I could do. I could say MEAN, mean, and then in parentheses, I'm going to just list out these numbers: 6, 10, 13, 2, 15, 22, 10, and then 4, 4, 4, giving us an answer of 9. How easy. Next question. If the business, it says, cares for 16 reptiles and the number of reptiles is R, that means that R is 16 in this equation, right? So let's get this equation into Desmos. 2.5b plus 5r equals 80. But they said that R was 16. So let me replace R here with 16. You could put it in parentheses if you want. Now the only problem is that Desmos isn't going to tell us how many birds, which is B, because it doesn't like variables that aren't x's or y's. So let's erase the b and just replace it with x. Okay? And now you could see it drew a purple line through the x-axis at 0. So the x value, or the b value, is 0. In other words, if this business cares for 16 reptiles, it doesn't have any room to care for birds. Okay? If you solve this equation for b, plugging in 16 for b is going to equal 0. Okay, so we get 0. Let's go to the next question. We've got a cube. 41 inches is the length of the edge of the cube. What's the volume? We can see in the reference table here that the volume of a box, essentially, is length times width times height. But with a cube, all of the sides are the same. That's what makes it a cube. And so really, it's just side cubed, right? Side times side times side, length times width times height. So 41, we just need to cube it. We can do that easily in any calculator, but Desmos works just fine. And there's our answer, 68,921, D. 13 is p% of 25. What's the value of p? So it's basically saying 13 out of 25 is what percentage? Okay, that's kind of what it's saying. So let's do it. 13 out of, meaning divided by 25, and we get 0.52 in Desmos. Well, 0.52 is 52%, so the p-value is 52%. This one here, we've got a starting population of 15,000, and then each year the population increases by 4%. So it says, which equation represents this model? Well, this is a kind of a classic setup of an exponential function. We know it's that because it's increasing by a percentage, and that's going to be exponential. It's exponential growth. Now, the number in the front of the parentheses is always going to be the initial value, in this case 15,000. So right away we know it has to be either C or D because we need 15,000 in front of the parentheses. That's our initial or starting value. So that means we could eliminate A and B. Now, because it's increasing by 4%, the number in the parentheses has to be greater than 1. If it's less than 1, like in C, that would be a decrease, in this case of 4%. But they specifically say it's an increase. And so our number in parentheses has to be bigger than 1. You could probably see why it's 1.04 because 4% is 0.04. So the answer would be D. Next one, this is a good Desmos question because it's an equation, but it's really tricky to solve. Well, for most of us, it's going to take us a little time to solve it. And so we'll go to Desmos, and it's going to be really easy in Desmos because we're just going to type it in exactly as we see it. And notice there's two solutions, but they want the positive solution. And so the positive solution is 2.25. Uh-oh, they don't give us that choice. Obviously, though, it's not C or D, so we could cross those out. Which of these two is 2.25? Well, Desmos will tell us if we just divide these in Desmos. 7 divided by 4 is 1.75. A is wrong. B must be the answer because if we do 9 divided by 4, there we see it, 2.25. So B is our answer. Here, this is one that we're not going to be able to use Desmos on. It's a standard deviation question. And it says, which statement best compares the standard deviations of the numbers of glue sticks brought in by each student for these two classes? Now, before you look at the answers, look at these dot plots. They are identical except for the numbers at the bottom. But that doesn't matter for standard deviation because if the data is equally spread out, as we see it is in both Class A and Class B, then the standard deviations are going to be the same. I'll say that again. It doesn't matter what the actual numbers are in the data. As long as the spread of the data is identical, which it is, the standard deviation will always be the same. And so we could say that B, the standard deviation is equal in both of them. And that's our answer. This one's interesting. It's starting to get a little harder here. It says that, we've got a function. And it says for how many values of x, so how many different x values, does f of x equal 0? In other words, the function, the value of the function f of x is 0. Well, think about it. Where is the function equal to 0? Another way to say it is, remember, f of x is really the same thing as y. Hopefully you've learned that before. So f of x and y mean the same thing. So where would y be equal to 0? Right? F of x is the same as y. So where is y equal to 0? Well, y is equal to 0 on the x-axis, right? Every point on the x-axis has a y coordinate of 0. In other words, what they're asking us for basically is how many times does the graph cross the x-axis? That would be where y or f of x is 0. So it happens once, twice, 3 times. They don't ask for those specific values of x. They just say for how many values of x. And so it would be 3. 3 times it crosses the x-axis. There's 3 intercepts, and that'd be our answer. Okay, here's another one that we could use Desmos on. It's an exponential function. I know I can use Desmos because they're asking about a graph. They're asking me for the function's value at 4. These are all good hints that we can go to Desmos and use it. So let me clear out what I already had in there. I don't like that it doesn't do that for me. I wonder if there's a way that I could refresh it, but I'm not sure. So I'm going to type in that function, g of x, and I'm going to put in the g of x part. I'm not going to just say 19 times a to the x. So g of x equals 19 times a to the x. And it says we could add a slider. We can maybe do that later. G of 3, it says, equals 2375. So if I put that in, Don't know if this is going to help us at all yet. But we need to figure out this A value. Okay, so if we only knew A, we would be able to figure this out a little bit. Okay, let me expand it. You notice what I did there? I hit expand. You could collapse it. That gives us a little more space. That's kind of nice. Maybe I should have done that earlier. Okay, and we need to figure out what the value of g of 4 is. Well, what I'm going to do is I'm going to add a slider, and I'm going to now adjust the a value. So this is changing the a value in the function. And for example, if a is 4, then we get this nice graph. Let me zoom it out. Remember that we need to find, oh, this is what I want to do. So if g of 3 is 2375, then that means that x is 3 and y is 2375. So that point that I just wrote is on the graph. So let me zoom it out so that I could see that point up there. See it? Let's zoom in just to that point, and let's see if we could figure out what's going on. So if I've got, you could see that the function as I have it isn't going through that point. But remember, if that point is on the function, then the function has to go through the point. So let me adjust my a value until I get the function to go through the point. And notice that when a is 5, it goes straight through that green point that we know it should. So that tells us, after all that work, we know now that a has to be 5, okay? So I'm going to go back to the function. I'm going to replace a with 5, okay? And now I need to figure out what g of 4 is. So we know g of 3 is 2375. We don't need that anymore. I'm going to get rid of all this stuff. And all I need to do now is replace this 3 with a 4, and it's going to tell me what the value of g of, oh shoot, g of 3 is supposed to be 2375. Oh, I see what it's doing. G of 3 is 2375, like we knew, but g of 4 now, if I replace it, it tells me it's 11,875. So that took us a little while to get to it, but we were able to use Desmos, and we did it a little sloppily, but hopefully it makes sense the way we did it, right? So let me just refresh what we did. We put in the function just as we saw it. We knew this point 3, comma, 2375 is on the function. So we drag the slider until we find the a value that goes through that point, or makes the function go through the point, and then we're able to find g of 4. Okay? Hopefully that makes sense. Now we need a solution to a system of equations. Pretty easy, because we should just be able to type this into Desmos and find the solution really, really quickly. If I hit this home button, you may have seen our videos before, that takes me back to the default zoom on Desmos. So I was really far away from the origin. That brought me right back. So let me type these in. We need the solution, they say. Remember, a solution to a system is the intersection point. So we just want to find where these two graphs intersect each other. They intersect at this point right here, 2, 0. There it is, see, simple. Desmos made it really quick. This one is not one that we could use Desmos for, so we'll get rid of that. They say that FJH, this triangle, is similar to triangle JKL, and angle F corresponds to angle J. So if we want to find the sine of angle J, and they've already given us the sine of angle F, guess what? Similar triangles, their angles that are corresponding to each other, like F and J are, have the same trig values. Let me say that again. Similar triangles, their angles that are corresponding to each other in the same place, they have the same trig values. So you don't need to draw this out. This isn't very complicated. If the sine of F is this crazy fraction, the sine of J will be that same fraction because F corresponds to J. They have the same value, the same trig value, because their angles are the same. Okay, they're corresponding to each other. How about this one? This one we could use Desmos for. We don't need to, but it looks like a complicated exponential function. But don't worry, it's going to be pretty quick. How much time in minutes does it take for the number of bacteria in this population to double? Well, double, notice, is multiplying something by 2. And guess what? Sure enough, we are multiplying our number by 2. That's what the parentheses means when it's 2. So if we want to take this initial population, remember we said in an earlier question that the number in the front is the initial value. If we want to take 60,000 bacteria and double it, we just need to do 60,000 times 2. In other words, this exponent doesn't need to be there. We want to just get rid of it, right? Because if it was 60,000 times 2 without any exponent, we'd already be doubling it like they asked us for. So the question is, how can I make this exponent just be a 1? Right? If I have 2 to the first, it's the same thing as 2, which is how we're going to double it. So I essentially just want to figure out, how can I make t over 410 equal to 1? Well, at this point, I could use Desmos if I want. T over 410 is equal to 1. But again, it doesn't like t's, it likes x's and y's, so let me make this an x. And if I zoom it out, I can see that the answer is 410. Right? 410 divided by 410 is 1. So t has to be 410. In other words, after 410 minutes, the bacteria will have exactly doubled. Next question. Okay, we can't use Desmos for this. At least I wouldn't. Yeah, I don't think you could. We want to express 4j plus 9 in terms of p and k. So we essentially want to solve this equation for this denominator, 4j plus 9. Well, how could I do that? Notice it's in the bottom here. So if I took that denominator and I multiplied both sides by it, I would be able to cancel it out on the right and move it to the left, right? And it would say, p times 4j plus 9 equals k. But then I would have to divide out the p that's still on this side and move it over to the other side. By dividing it, it would be k over p. So essentially, I'm going to get A for my answer. The reason, when I see these questions, if I'm trying to solve for 4j plus 9, and I need to move this p to the other side eventually, I'm really just going to switch the places of these two things. P goes in the place of 4j plus 9, and 4j plus 9 goes in the place of p. See how it's that way in the answer? If you want to write it out, you can do what I said earlier, but you're going to end up getting A as your answer. Okay, moving right along. We see a question about two lines, P and R, and they're perpendicular. So what's the slope of line R? Well, line P is this equation. Maybe we could use Desmos for it. We definitely could. I don't know if it's the easiest way to do it, but we can show that we can do it in Desmos. 4y plus 8x equals 6. So what would the slope of this line be? Because we need the slope of the other line, right? They're perpendicular. Well, how could we figure this out? Well, this slope, or this line, we could write it in y equals mx plus b form. We can, let me go like this. Let's see if this is going to work. Let's add a table. And nope, I don't want to do that. I'm going to do this. Oh, I'm not able to do that. So what I think I'll do is I'm going to take these 2 points and I'm going to make a table with them. Okay, add item, put in a table. The two x values were 0, 1.5. So 0 is the x, 1.5 is the y. There it is. And the other one was 0.75, 0. So 0.75 and 0. Okay, let me get rid of this original equation. It's not going to help me to do it this way. So now I'm going to hit zoom. It's going to zoom it to those 2 points. And what I could do, if this works, is I can say y sub 1, which is referencing these values here, is approximately m times x sub 1 plus b. Now I'll explain how I did that, and then I'll tell you what it means. So how I did that is on my keyboard, I hit y, and then I hit the shift button and the minus sign, and that gives me that little subscript, like it lowers the text a little bit, and I could hit y1, right? And then I'm going to arrow over to get it back to the normal height. And then the approximately button, or key like that, is found by hitting shift and then the number or the key next to the number 1. Okay, you'll see that little squiggly. And it's approximating the value. Okay, so I'm basically saying, hey Desmos, tell me approximately the line that's going through these 2 points. And Desmos says, sure, here it is. -2 is the slope, the m value, right? Y equals mx plus b. That should look familiar. And b is 1.5. So the slope's -2. Now remember, these lines are perpendicular. And so lines that are perpendicular have negative reciprocal slopes. So they have to be the opposite sign of each other and reciprocals. Well, what's the negative or opposite reciprocal of negative 2? It would be positive 1/2, because 1/2 is the reciprocal of 2, which is really 2 over 1. So 1/2 is our answer. Let's put that in, 1 over 2, like that, and that should be right. Okay, the next one. Point O is the center of a circle. The measure of arc RS on this circle is 100 degrees. What is the measure in degrees of its associated angle, ROS? So this is not something we can do Desmos, but if you think of a circle, I often think of like a 90-degree angle or a 180-degree angle. But basically, if the arc on the outside is 100 degrees, the angle that goes from the center, right, O is the center, so ROS would go through the center. Kind of hard to explain without drawing a picture, but hopefully you could picture it. It's going to have the same angle as the arc angle, 100. So it's simply going to be 100. This one, which of the following could be the equation of the graph shown? Well, I know that the, first of all, it's upside down, and so the leading coefficient has to be negative. Okay. I also know that there are, let's see, so the end behavior, maybe you've learned this, but it goes down and it goes down. It should remind us of a quadratic, which has end behavior that either goes like a U shape, so it goes up and up, or if it's upside down, it goes down and down. So it could be a quadratic. However, it's like there's a few humps in here, and so it can't be a quadratic, which doesn't have all these bumps. But it has to have an even number of roots. Like a quadratic is 2 roots, right? X squared. This is going to be either x to the 4th or x to the 6th because of the end behavior. Okay, so it has to have 4 roots. And the only ones in here that have 4 solutions or roots are going to be B and D. Okay, how come A is wrong? Well, here's 1, 2, 3 roots or x-intercepts. Same in C, 1, 2, 3. But in B and D, because they have a parentheses that's squared, that counts as 2. So this has 2, 3, 4 x-intercepts. So does D for the same reason. So it's one of those two, okay? And the second thing I notice is that the graph touches the x-axis at -5, but it turns back, right? Whenever we see it touch and turn back, that's a duplicate root. There's 2 of them. And so if it's at -5, first of all, that's going to correspond to x plus 5. Remember, if it's in parentheses in this context, it's really the opposite of what we think. So x plus 5 really corresponds to -5, and it's a duplicate here because it's x plus 5 squared. And so for all those reasons, B is the right answer. This one, don't need Desmos. The function f of x equals 201% of x. And so it's bigger than 100%, so it's increasing. Right away, it's not A or B. Those are decreasing. And because it's increasing by a certain percentage, like we saw in a question earlier, that is exponential. Oh, shoot, wait a second. I made a mistake here. So if it's 201% of x, remember, of always means multiply. And so 201% is really 2.01. So it would be 2.01 times x, or 2.01x. Now, if you go to Desmos and you put in 2.01x, you're going to see the line that goes up, but it's a straight line, so it's an increasing linear function. Be super careful here because it's easy to make the same mistake that I did. So the answer we get is D. Okay, here's a good Desmos question. We're going to type it in just like we see it. F of x equals 4x squared plus 64x plus 262. We can zoom it out till we see it. And g, it says, is f of x plus 5. So now we type in g of x equals f of x plus 5. You could see that g and f are basically the same graph, except it's shifted over by 5 to the left. Hence the x plus 5, right? It's 5 to the left because it's the opposite in the parentheses. 5 is really negative. So what's the minimum? Or for what value of x does g of x, the red one, reach its minimum? It's at an x value of -13, A. Here, we can use Desmos eventually, but first, it's a poll. 803 voters were selected at random. That's what these two add up to. 483 and 320 make up 803. And it says, according to the poll, if 6,424 people vote in the election, by how many votes would Angel Cruz be expected to win? First of all, Angel Cruz is winning in the poll by, let's see, 483 minus 320. He's up by 163 in the poll. The question is, how many times bigger than the poll is the actual election amount of voters? 6424. So let's do this. 6424 divided by the polled amount of people, 803, it's 8 times as many people. So that means that if he was going to win in the poll by 163, he should win by 8 times that amount in the actual election, because the number of people in the election is 8 times more. So let's just do 163 times 8. 163 times 8, 1,304. There's our answer. And finally, this is the last question. We can go to Desmos. We love Desmos. And we've got 6 minutes left, so we've got time for this one, hopefully. And I'm going to type it in as I see it. Now, they say that this system intersects in exactly 1 point. That's our key. So type them in. Y equals 3x plus a. And let me expand this so we could see it a little better. I'm going to add a slider. And remember, they said that they intersect in exactly 1 point. So let's find out how we can get them to intersect in 1 point. Let's drag the slider. And it seems like if I go smaller, that eventually the red line is going to cross, boom, like right around there in this 1 point, which is 610. So a is negative 8. But be careful. They don't ask for the value of a. Sometimes they will. But they say, what is the value of x? So a is negative 8, but x isn't negative 8, because x is the x value at the intersection point, which was 610. So x has to be 6, and we get an answer of C. Okay. Now they're going to give you the option to check your work. You certainly could if you have time. And when you're taking the actual SAT, check your answers. Okay, if you have time, might as well do it. But I'm going to submit it. I'm all done. Hopefully that's helpful. I want to reiterate that Desmos you could use on every single question on the math section of the SAT. You don't have to use it. You could still use your regular calculator that you bring to the test. Maybe you're more used to it, but hopefully by watching this video and a lot of our other ones, you see how quick and easy it is to use Desmos, which has a lot of features that maybe your actual calculator doesn't have, or maybe you don't know how to use those features. So I would recommend getting familiar with Desmos, get comfortable with it, do these Bluebook tests. Hopefully you've still got some that you can work on your own before your actual digital SAT. Let us know if you've got any questions. Let me know if I made any mistakes. I was going through that pretty quickly, and I know I make a lot of mistakes. So let me know in the comments if there's something that you want to see in the future, a video on, or if I made any mistakes. If you want to check out our course, we designed at Method Learning our own digital SAT course with brand new questions, brand new content, and strategies for acing the digital SAT, reading and writing section, and math. So if you want to check that out, there's information in the description of this video with a coupon code for you to get the courses at a huge discount. So check that out, and we'll see you next time.